Hello everyone. In Chapter 10, we focus on the first section that covers hypothesis testing. This section of Chapter 10 should help you a great deal with your project for the course. To begin with, looking at the definition of a hypothesis, we go back to what we've talked about in class. And remember that a hypothesis is a statement regarding a characteristic of one or more populations. Basically, it's a statement that something is going to happen or will happen, kind of like an expectation that you're having. Examples of claims regarding a characteristic of a single population. One example would be in 2008, 62% of American adults regularly volunteered their time for charity work. A researcher believes that this percentage is different today. Another, according to a study published in March 2006, the mean length of a phone call on a cellular telephone was 3.25 minutes. A researcher believes that the mean length of a call has increased since then. Using an old manufacturing process, the standard deviation of the amount of wine put in a bottle was 0.23 ounces. With new equipment, the quality control manager believes the standard deviation has decreased. A word of caution from section 10.1, if population data are available, there is no need for inferential statistics, meaning you have all of the available data because you're looking at the full population. So now we look at hypothesis testing. This is a procedure where we're looking at sample evidence and probability. We're using that to test statements regarding the characteristic of one or more populations. The steps in hypothesis testing are shown on this slide. You make a statement regarding the nature of the population. You collect evidence, which is sample data, to test the statement, and you analyze the data to assess the plausibility of the statement. Remember that I told you that you need a null and an alternative hypothesis. The null hypothesis, denoted H sub 0, is a statement to be tested. The null hypothesis is a statement of no change, no effect, or no difference, and is assumed true until evidence indicates otherwise. The alternative hypothesis, denoted H sub 1, is a statement that we're trying to find evidence to support. In this chapter, there are three ways to set up the null and alternative hypotheses, and we'll look at those three. Equal versus not equal hypotheses. That's called a two-tailed test. You're either looking at your parameter equaling some value with your null hypothesis or your parameter not equaling some value with your alternative hypothesis. Equal versus less than is left-tailed test, meaning for your null, your parameter equals some value. Your alternative, your parameter is less than some value. So then a right-tailed test, again, your null, your parameter equals some value. Your alternative is that your parameter is greater than some value. And we'll look at a few examples. The null hypothesis is a statement of status quo, or no difference, and always contains a statement of equality. The null is assumed to be true unless we have evidence to the contrary. We seek evidence that supports the alternative hypothesis. For each of the following claims, determine the null and alternative hypotheses. State whether the test is two-tailed, left-tailed, or right-tailed. We're going to start out with A. In 2008, 62% of American adults regularly volunteered their time for charity work. A researcher believes that this percentage is different today. This hypothesis is looking at a population proportion if the percentage participating in charity work is no different than in 2008, it will be 0.62 or 62%. So the null hypothesis is basically P equals 0.62. Since the researcher believes that the percentage is different today, the alternative hypothesis is a two-tailed hypothesis, meaning that our population proportion does not equal 0.62. When it states that there's basically some difference and it doesn't say greater than or less than, it means it could be more than, it could be less than, and that's why we're calling it two-tailed. For B, according to a study published in March 2006, the mean length of a phone call on a cellular telephone was 3.25 minutes. A researcher believes the mean length of a call has increased since then. The null would be there is no change, that our mean is 3.25. The researcher believes the mean call length has increased, so that would mean that the mean is greater than 3.25. That's a right-tailed test. One easy way to remember if it's right-tailed or left-tailed, write it out like this, and when you see the greater than sign, think of it like an arrow pointing to the right. It's a right-tailed test. Your results will fall to the right of that calculated mean. C says, using an old manufacturing process, the standard deviation of the amount of wine put in a bottle was 0.23 ounces. With new equipment, the quality control manager believes the standard deviation has decreased. The null would be basically that it's unchanged. Okay, so it's 0.23 ounces. The alternative would be that it's less than 0.23. Okay, when I see the less than sign, it looks like an arrow pointing to the left. We call that a left-tailed test. It means our possible standard deviation values will fall to the left of that standard deviation. There's 4 outcomes from hypothesis testing. One would be to reject the null hypothesis when the alternative is true. This would be a correct option. Another would be to not reject the null hypothesis when the null hypothesis is true. This is also a possibility for being a correct answer. 3 is to reject the null hypothesis when the null hypothesis is true. This is incorrect, and this is called a type 1 error. So when we reject the null hypothesis when actually the null hypothesis is the correct one, that's a type 1 error. 4, do not reject the null hypothesis when the alternative hypothesis is true. This would be a type 2 error. So in this instance, let's say our alternative hypothesis is true, but instead we accept the null hypothesis, which would negate the alternative hypothesis. This is a type 2 error. For each of the following claims, explain what it would mean to make a type 1 error. What would it mean to make a type 2 error? So A is going back to the 62% of American adults volunteering their time, and B, looking at the mean length of a phone call being 3.25 minutes. We're going to start with A. So in 2008, 62% of American adults regularly volunteered their time for charity work. A researcher believes this percentage is different today. A type 1 error is made if the researcher concludes that P does not equal 0.62 when the true proportion of Americans 18 years or older who participated in some form of charity work is currently 62%. A type 2 error is made if the sample evidence leads the researcher to believe that the current percentage of Americans 18 years or older who participated in some form of charity work is still 62% when, in fact, this percentage differs from 62%. Looking at B with the mean length of a phone call of 3.25 minutes, the researcher believes the length of a call has increased since then. A type 1 error occurs if the sample evidence leads the researcher to conclude that the mean is greater than 3.25 when in fact the actual mean call length on the cellular phone is still 3.25 minutes. A type 2 error occurs if the researcher fails to reject the hypothesis that the mean length of a phone call on a cellular phone is 3.25 minutes when in fact it is longer than 3.25 minutes. So this slide just kind of sums it up where we could have our type 1 error or our type 2 error, and then also our options of what that means. So the type 1 error, rejecting the null when the null is true. The type 2 error, not rejecting the null when the alternative is true. The probability of making a type 1 error, which we call alpha, is chosen by the researcher before the sample data is collected. The level of significance of alpha is the probability of making a type 1 error. So in other words, as the probability of a type 1 error increases, the probability of a type 2 error decreases, and vice versa. Here at the end of this section, we look at another word of caution from Chapter 10. We never accept the null hypothesis, because without having access to the entire population, we don't know for exact assurance that we can accept the null hypothesis. So rather than accepting it, we say we do not reject the null hypothesis. It's just like in the court system. We never declare a defendant innocent, but rather say the defendant is not guilty. According to a study in March 2006, and this goes back to the cellular telephone example, our mean phone call length is 3.25 minutes. A researcher believes that the call time has increased since then. Suppose the sample evidence indicates that the null hypothesis should be rejected. State the wording of the conclusion. And B, suppose the sample evidence indicates the null hypothesis should not be rejected, and state the wording of that conclusion. For A, and this is supposing the sample evidence indicates that the null hypothesis should be rejected. So the statement in the alternative hypothesis is that the mean call length is greater than 3.25 minutes. Since the null hypothesis is rejected, there is sufficient evidence to conclude that the mean length of a phone call on a cell phone is greater than 3.25 minutes. This would be correct wording for that. In B, suppose the sample evidence indicates that the null hypothesis should be rejected. State the wording of the conclusion. Since the null hypothesis is not rejected, there is insufficient evidence to conclude that the mean length of a phone call on a cell phone is greater than 3.25 minutes. In other words, the sample evidence is consistent with the mean call length equaling 3.25 minutes. Okay, so this wraps up section 1 of chapter 10. That's all we'll be covering in this chapter. As always, let me know if you have any questions.